The following slideshow is a basic tutorial on how train movements are controlled and specifically how railroad trackside signals are used. We are all familiar with the traffic laws that dictate how cars use the roadways. These rules of the road are needed to keep traffic flowing in an orderly fashion, and traffic control signals play a very important part. Traffic signals operate automatically by either detecting the presence of a vehicle at an intersection or by a timer, or both. And they look and mean pretty much the same thing wherever in the US and Canada they may be. Train movements are much more complex for several reasons. Trains cannot swerve to miss objects ahead or pass another train. Trains cannot stop within sight distance of anything on the track ahead. Trains can be more than a mile long. Therefore, control systems for trains are much more complex, and that includes the signal systems. Signals are also used to pass other instructions to a train crew, such as speed limits and diverging routes ahead. As you watch the model railroad nearby, built by the members of the Central New York Modelers, you will see several operating signals. These signals are set up to work like signals on a real railroad. Let's familiarize ourselves with some basic information and terminology about train movements. Railroad track is divided into sections known as blocks. Unlike a block on a city street, which runs from an intersection of a cross street to another cross street, a block is simply a defined length of track. A block can be any length, less than a mile long in congested areas, or many miles long on more lightly used routes. There may or may not be track diverging from the main track or a crossover between two tracks within a block. Unlike a block on a roadway, only one train at a time is allowed to occupy one track in a block under normal circumstances. Entrances to a block are usually guarded by signals, as shown in the diagram below. Many blocks together make up a territory. As an example, think of a territory as the length of Erie Boulevard East from downtown to DeWitt. Note that there are many blocks within this territory. The number of blocks in a territory is generally determined by how much traffic is on the line. A main route is usually 2 or more tracks wide, with crossovers between the two tracks at regular intervals. Train movements within a territory are controlled by a dispatcher. Think of the dispatcher as the air traffic controller of the railroad. It is the dispatcher's job to route trains through his or her assigned territory safely and efficiently. A dispatcher sits at a desk with several computers that display what blocks are occupied, the indication of all signals, and the position of all turnouts on the route. The dispatcher uses the computers to set the route that a train will take and to monitor the location of trains in their territory. Many dispatchers sit in the same large room and hand off their trains to the dispatcher for the next territory as the trains move along the track. This is known as centralized traffic control. Note the large map in the picture to the right, which shows all the territories that the entire dispatch center controls. The colors indicate the status of each block. On less congested routes, or on routes with very long blocks or few diverging tracks, one or both of the following may be used to control train movements. In automatic block signaling, or ABS territory, signals are used, but they are controlled only by the presence or absence of a train in the block or blocks ahead. Some territory may not have signals at all. This is referred to as dark territory. Train crews receive permission to occupy a block or blocks and other instructions verbally from a dispatcher, almost always by radio. Permission to occupy a block of track is called a track warrant, and the instructions are copied down on a standard form known in the Northeast as a Form D. The completed Form D is repeated back to the dispatcher to make sure the train crew understands their orders before they are allowed to proceed. After the orders are in effect, the block or blocks of track are considered to be controlled by the train crew who received the track warrant. It is important to note that the dispatcher must know where all trains are within their territory at all times, whether train movement is controlled by CTC, ABS, or the territory is dark. You are familiar with the aspects of traffic lights on the roads, right? Green means go, amber means prepare to stop, and red means stop and wait for green. In some cases, colored arrows give a stop or go indication for a particular direction, but that's about it. Signals on the railroad display many more aspects than a standard highway traffic light. Railroad signals display different aspects using a combination of the following: 1, 2, 3, and occasionally more lamps may be lighted at once. 4 different colors are used: red, yellow, green, and less often lunar white. Lamps may be on steady or flashing. Position of lights on the signal head or by position of semaphore arms. Shape, color, or lettering of signs attached to the signal mounting structure. You can see that many combinations of indications are available. For example, a 2-head signal like the one pictured above right has 13 possible combinations listed in the standard rulebook. Also, many different styles of signal are in use. As an engineer or conductor, you would be responsible for knowing the meaning of all possible combinations of all signals that you may encounter on the route that you are assigned to. Speed limits are important for safe operation of trains, just as they are important for safe operation of cars on the roadways. Safe speed limits on streets and highways are calculated by the engineers designing the road and apply to all types of vehicles using it. Speed limits on the railroad, however, are variable. Speed limits change based on the length and weight of the train, distance the next train on the track is ahead of the locomotive, the speed rating of the track, and what the train is carrying. Passenger trains, being shorter and lighter than freights, generally have higher speed limits, while trains carrying hazardous materials may be limited to much lower speeds. Maximum speed limits may or may not be posted along the track, and speed limit reductions are conveyed to the train crew by the indication of signals or by orders from a dispatcher. Train speeds are defined in the rulebooks and generally are as follows. Normal speed is the maximum authorized speed for the track or your train, whichever is slower. Limited speed equal 40 miles per hour for freight trains and 45 miles per hour for passenger trains. Medium speed is 30 miles per hour. Slow speed is defined as 15 miles per hour. And restricted speed tells the engineer that he must be able to stop within 1/2 the range of vision of anything on the track ahead and never more than 20 miles per hour or 15 in some territories. In the next 2 slides, let's take a look at a modern 2-head vertical signal, each head capable of displaying red, yellow, and green. This is probably the most common arrangement found in use today. We will look at 6 commonly used indications and their meanings. 4 of the examples also show the same indication on a single head signal. Green over red, or green by itself on a single head signal means clear, proceed at the maximum speed allowed for your train, or maximum track speed, whichever is lower. Yellow over red, or yellow by itself, is called an approach. The engineer must slow his train safely to a medium speed, which is usually 30 miles per hour. He will probably encounter a stop indication at the next signal. Red over red, or red by itself, means stop. The engineer is required to bring the train to a safe stop and wait for a more favorable signal before proceeding. Here are 3 more signal indications. Red over green is a medium clear. The train will be moving through a turnout, and it is safe to do so at maximum speed allowed for the turnout or the train, whichever is lower. They may resume normal speed when the entire train has cleared the turnout. Red over yellow is a restricting signal. The train may proceed at restricted speed until the entire train has cleared all turnouts and the locomotive has passed a more favorable signal. Flashing yellow over red, or flashing yellow by itself, is an advanced approach. The engineer must proceed prepared to stop at the second signal that he will encounter. So far, we have only seen 6 indications from a 2-head vertical signal. This chart shows diagrams of the many different signal styles in use and the different indications commonly used on Northeast railroads. Imagine having to know all these to drive your car. Members of a train crew need to learn the indications of all signal types they will encounter and their meaning as part of their certification process. Let's take a look at some different styles of signals used by the railroads throughout history. One of the earliest style of trackside signal was simply a large, brightly colored ball tied to a rope or chain, which ran through a pulley on top of a pole so it could be raised and lowered. These signals occasionally were fitted with lanterns or flags. These were coming into common use in the 1830s. When the ball was hoisted to the top of the pole, it signaled "clear track ahead, proceed." When the ball was lowered, it indicated to the engineer that they must stop the train. The term highball to indicate clear track ahead is still in common use by railroad crews today. Ball signals were controlled manually by a station attendant or control tower operator, as electric control circuits had not yet been developed. The attendant would lower the ball when a train passed the signal, then raise it again after a specific period of time. This method was better than no signals, but it still depended on the train maintaining its prescribed speed after passing the signal. Over time, a few interesting schemes to operate ball signals automatically were tried, with limited success. The first electrically operated signal was the Hall disc signal, or banjo. Patented in 1867, this signal housed a metal hoop with red cloth stretched over it, which was attached inside a wooden banjo-shaped case in such a way as to allow it to swivel. When the red disc was showing, it meant stop. When the disc swung out of view, showing the white inside of the signal, it indicated clear. Some disc signals had a colored lens on top lit by a kerosene lantern, which showed red for stop. A major advantage of these signals over the ball and rope is that they were controlled electrically, therefore they could be located away from stations or manned signal towers. The first major user of the Hall disc was the New York and New Haven Railroad, which began installing them in 1870. Semaphore signals were developed in the 1860s and were in widespread use by 1890. Semaphores display 3 signal indications, both by a moving arm and by colored lenses in front of a lamp, so the signal could be easily seen both during the day and at night. The color of the arm and the shape of the tip of the arm could convey more information about the territory ahead. There are a few semaphore signals in use today, mainly in the Midwest. Most have been replaced by more modern styles. As they are considered obsolete, they are not included in the current NORAC rulebook. 2 main types of semaphores were used. Keep in mind that on both styles of signal the arm could be in 3 positions. On upper quadrant semaphores, the arm would be straight up to indicate clear track ahead, at a 45-degree angle to indicate an approach or medium speed, and at 90 degrees to the pole to indicate stop. On a lower quadrant semaphore, the stop indication would still be displayed with the arm at 90 degrees to the pole. However, the arm would drop instead of raise to display the approach and clear indication. The upper quadrant version was generally preferred for safety reasons because if the signal failed, the arm would drop, displaying a stop indication. Around 1915, the position light signal was developed by and for the Pennsylvania Railroad. The basic position light signal is equipped with 6 lamps arranged in a circle around a 7th lamp mounted to a round black target. By lighting 3 lamps at a time, the signals imitated the pattern of an upper quadrant semaphore. The amber color, developed by Corning Glass for the Pennsylvania Railroad, was used because it penetrated fog. As train movements became more complex, two signal heads were combined on the same mast, or additional lights were added around the outside of the signal head to enable it to display more aspects. There were also ground-mounted or dwarf varieties. A very similar signal eliminated the center lamp and used colored lamps around the outside of the target, creating what rail fans call color position signals. These were developed around 1920. The first major user of color position signals was the Baltimore and Ohio, and many can be seen today, especially on Amtrak territory in the Northeast Corridor. Up to 6 lamps, known as markers, were added around the outside as desired. As other railroads took over former Pennsylvania Railroad trackage, many position light signals were easily converted to this style. The General Railway Signal Company of Rochester, New York, developed the triangular colored light signal, which was one of the first widely used high-intensity light signals. The GRS Type G, or tri-lights, were widely installed by the New York Central and the Seaboard system, and later Conrail and New Jersey Transit adopted this signal. Another advantage of the tri-light is their small size makes them ideal for confined locations. There are still a good many of these in use in the Northeast United States, including upstate New York. One of the most widely used signals is called the searchlight. Invented in 1869, these signals were produced until the 1980s. A mechanical arm moves 3 different color filters in front of a single lamp and lens array. The lenses are made to produce a very narrow beam of light that can be seen from a long distance, even with a low wattage lamp, even in full daylight. As many individual signal heads can be mounted to a single post to produce a signal as simple or complex as needed for a specific application. Although still widely used today, they are being phased out in favor of signal styles with no moving parts. Today, many railroads are standardizing on a signal head with the lamps in a vertical orientation. 2 or 3 lamps per head may be used. As with other styles, multiple signal heads can be combined to form one signal, and there are several types of dwarf versions in use. Some varieties have one large slanted snow shield as shown above right, earning them the nickname Darth Vader signals. These signals have no moving parts, making them more reliable than some other types. Also, signals using LED lamps are starting to appear. As the CSX Railroad, the East-West Railroad through Syracuse, replaces signals, they are using this style. Many locomotives on major railroads are equipped with miniature versions of trackside signals in the cab of the lead locomotive. Cab signals mirror the indication of trackside signals along the route and continue to display the aspect of the last signal the train passed. This eliminates the possibility of an engineer forgetting the aspect of the most recent signal that they saw. New technologies are being developed that will link cab signals into the train controls to slow or stop a train if the speed of the locomotive exceeds the speed allowed by the signal. This is part of a new safety system known as Positive Train Control, or PTC, that is coming into use nationwide. This is the cab of Amtrak number 186, a P-42 DC Genesis built by General Electric Transportation Systems. Note the cab signal on the post between the windshields as part of the array of modern control systems. Safe operation of trains is the railroad's first concern. Therefore, there are many safety systems in place. In the next few slides, we will look at a few of them. In 1985, 6 Northeast railroads formed NORAC, the Northeastern Operating Rules Advisory Committee. Their goal was to enhance safety and ease of operation by standardizing rules and operating procedures among their member railroads, which previously each had their own rule books. Today, over 40 railroads, from large national companies to small short lines, share a common rulebook. These changes included standardization of signals and their meanings, safety and operating procedures, dispatching procedures, standardization of forms and terminology, and many other items. It is interesting to note that while most railroads east of the Mississippi belong to and participate in NORAC, many western railroads formed a similar but separate group. Reviewing and updating rules is an ongoing process. The NORAC rulebook can be found online by typing NORAC into your favorite search engine. Signal systems have many built-in fail-safes. Block detection circuits, built into the track, work with local trackside logic circuits to monitor the presence or absence of trains in the block, the position of turnouts, and the signal indications along the route. This data is sent to the dispatch center via fiber optic cables, telephone lines, or radio. Signals and turnouts are interlocked, meaning that a dispatcher cannot change a signal from a stop to a more favorable indication and cannot move a turnout until the block detection circuit is satisfied that the track ahead is clear. All track control and signal circuits are designed for fail-safe operation, meaning if a failure occurs anywhere in the signal, the trackside logic circuit, or the control system, all signals in the affected area will display a stop indication and cannot be changed until the error is found and fixed. It is the locomotive engineer and train conductor's responsibility to know the meaning of each indication and the type and location of each signal on the territory in which they operate, in addition to the speed limits, location of grade crossings, etc.
CSX Equipment Defect Detector. Milepost 2-9er 1.9er. Track 2. No defects. No defects. Total axle 364. Speed 15. End of transmission.
You are listening to a talking defect detector. These detectors, placed at regular intervals along the track, monitor passing trains for overheated wheel bearings, wheels, brakes, axles, and undercarriage parts. Many of these detectors also look for dragging equipment and over height or over width conditions. This automated equipment reports defects to the train crew via radio in its mechanical voice. If defects are found, the engineer must immediately bring the train to a safe stop, report this to the dispatcher, and the crew must inspect the train. The train cannot be moved until the problem is found and fixed. Sometimes, if the problem is not severe, the dispatcher will give permission to move the train to a siding or yard, almost always at restricted speed. A brake test must be performed every time cars are added or removed from the train before they are allowed to travel on main lines. Locomotives undergo a daily safety and mechanical inspection. By comparison, cars and trucks are inspected only yearly. The inspection includes the braking system, wheels, calibration of the speedometer, and fuel system in addition to the normal items, lights, horn, windshield wipers, etc., and all fluids are checked and topped off. Tracks are routinely inspected. During hot weather, tracks are patrolled to look for rails warped from the heat. The railroad uses trucks with special wheels that make them able to run on the rails. These are known as high rail vehicles. The Federal Railroad Administration, or FRA, tests the condition of tracks using a special train car that is loaded with sophisticated test equipment. This equipment tests the rails for gauge, that's the distance from one rail to the other, level, flatness, warped rail, bad ties, loose mechanical joints, bad welds, and other defects. Ultrasound is used to inspect the metal for stresses that cannot be seen with the naked eye. The railroad can be ordered to reduce speed limits or close bad sections of track until the defects are fixed. All railroad employees are required to strictly follow the rule book. It is essential that speed limits, signals, safety regulations, and train orders are strictly adhered to by trainmen. Maintenance of way workers, car and locomotive mechanics, yard hostlers, and inside personnel have their own regulations to follow. Railroad workers are trained and retrained in safe performance of their assigned duties. Train crews are routinely spot checked by inspectors. Train crews generally work on an on-call basis. Therefore, to prevent hazards from tired workers, train crews are allowed to work for 10 hours and no more, after which they must be allowed 12 hours of uninterrupted off time. If any member of a train crew hits their time limit, referred to as going outlaw, the train must stop wherever it may be and a replacement crew brought in before the train is allowed to move. Railroad employees are not allowed to use cellular telephones, music players, or other personal electronics for any reason while on duty. The only exception is using a cell phone to contact a dispatcher in an emergency situation or if the train radio fails. Railroad personnel may be required to submit to drug or alcohol testing at any time. Penalties for safety violations are severe, with 30-day non-paid suspension being typical for a first offense and dismissal for 2 or more related violations. Thanks to everyone who contributed to this slideshow. For more detailed information on railroad signaling, go to www.railroadsignals.us. A great deal of the material used in this slideshow came from that website. Another reference is Railroad Signaling by Brian Solomon, published by Voyager Press, available through the Onondaga County Library System. This slideshow was edited and narrated by Andrew Slough, with support provided by the members of Central New York Modelers, the IT department at the Most, owners of www.railroadsignals.us, and others. Photos, video, and material provided by Eric Haas, Todd Sestero, Richard Schumacher, Stan Feldman, John R. Roma, Brian Solomon, Pentrex Railroad Video, and Andrew Slough. All material is copyrighted and used with permission. Please enjoy the model railroad, and thanks for visiting us today. Members of the Central New York Modelers are here most Saturdays and Sundays to answer any questions that you may have.